Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Doper Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to continue with where we stopped in the last lesson. So please, if you have not watched the last lesson or few other lessons back, I urge that you at least take up some time to watch them so that you don't get yourself confused just in the middle of the lessons. So we solved question 8, 9, and 10. We want to look at question 11, 12, and 13. So question 11 says y equals to e raised to the power x, e raised to the power minus x, e raised to the power x plus e raised to the power minus x. Now this question is one of the hyperbolic functions. We will see that later. So because this has to do with a fractional form, a numerator and a denominator, so we can apply the quotient rule. So the quotient rule says we must hold the denominator first. So we hold e raised to the power x plus e raised to the power minus x without differentiating, and then we differentiate the numerator. So the derivative of e raised to the power x is just e raised to the power x. The derivative of e raised to the power minus x is e raised to the power minus x times the derivative of this minus x. Now the reason why I did not say the derivative of x, because x coefficient is just positive 1. So the derivative of minus x is just equal to minus 1. Minus, quotient rule says minus. So we hold the numerator now, e raised to the power x minus e raised to the power minus x. And then we differentiate the denominator. So the derivative of e raised to the power x is just e raised to the power x. The derivative of e raised to the power minus x is e raised to the power minus x times the derivative of minus x, which is minus 1. All divided by the denominator e raised to the power x plus e raised to the power minus x, all squared. So now we can simplify it. So y prime now gave us, now let's multiply e raised to the power x times e raised to the power x. It's just e raised to the power 2x. Now remember, negative times this negative is positive, so this is positive. And then negative times this positive is negative, so this is not there again. So e raised to the power x times e raised to the power negative x. We add the powers, so it means x minus x is 0. So we have e raised to the power 0. E raised to the power minus x times e raised to the power positive x, again, is e raised to the power 0. E raised to the power minus x times e raised to the power minus x is just e raised to the power minus 2x, because when you're multiplying leg bases, you must add the powers. On this side now, we have e raised to the power x times e raised to the power x. It gives us negative e raised to the power x. Remember of this negative. E raised to the power x times minus e raised to the power minus x. It gives us positive e raised to the power 0, because x minus x is 0. Negative times negative is positive. So e raised to the power minus x times e raised to the power positive x is also 0. And then positive times negative is also positive. E raised to the power minus x times e raised to the power minus x is e raised to the power minus 2x. Negative times negative is positive, times this one is negative. All divided by e raised to the power x minus e raised to the power minus x, all square. So we can simplify now. E raised to the power positive 2x, and then okay, so let's observe somewhere around here. Let's observe so that we don't get ourselves confused. So this was, there was a negative here, right? So let's go over it right here, please. Let's go over it so that we don't get ourselves confused. So we held this denominator and we rewrite this one. Let's say we differentiate this. So the derivative of e raised to the power x is just e raised to the power x minus, so there was a minus sign here, right? The derivative of e raised to the power minus x is e raised to the power minus x times minus x, which is minus 1, times the derivative of minus x, which is minus 1. So this minus now and this gave us positive right here. So this is good. Now the next area is this one. So we held the numerator constant and we differentiated the denominator. The derivative of e raised to the power x is just e raised to the power x. The derivative of e raised to the power minus x is e raised to the power minus x, right? Times, okay, so this was positive, and then times the derivative of minus x, it gives us negative. Great. So let's multiply now. E raised to the power x times e raised to the power x is e raised to the power 2x. E raised to the power minus x, e raised to the power x times e raised to the power minus x is e raised to the power 0. E raised to the power minus x times e raised to the power x is e raised to the power 0. E raised to the power minus x times e raised to the power minus x is e raised to the power 2x. On this side, e raised to the power x times e raised to the power x is e raised to the power 2x. Okay, so this is 2x. So what do we observe? E raised to the power 2x can cancel e raised to the power 2x. And then e raised to the power minus 2x can cancel e raised to the power minus 2x. So y prime gives us, now e raised to the power 0 is 1, e raised to the power 0 is 1, so we have 4 all over e raised to the power x minus e raised to the power minus x all square. Now, one person can leave the answer like this, another person can say, no, I'm going to get rid of all of the negative powers. So in the numerator, you have 4. Down here, we have e raised to the power x minus. Now we reciprocate this expression. We're going to have 1 all over e raised to the power positive x, all raised to the second power. So we can find the LCD. So we'll find the LCD down there. So y prime is equals to 4 divided. The LCD for these two is just e raised to the power x. 1 goes into e raised to the power x is e raised to the power x times e raised to the power x is e raised to the power 2x minus e raised to the power x into e raised to the power x is just 1. 1 times 1 is 1. So this power now, we can say numerator carry its own power, denominator carry its own power. So this is 4. We change this sign to multiplication and reciprocate. So it's e raised to the power 2x, x times 2, divided by e raised to the power 2x minus 1 all square. So that the denominator is positive, not minus. This denominator is positive. So finally, we can just say y prime is equals to 4 e raised to the power 2x all over e raised to the power 2x plus 1 all square. So you can decide to maintain this as your answer. 4 all over e raised to the power x plus e raised to the power minus x all square, or you can further simplify it like this to get rid of the negative powers. Now let's move to question number 12. So question 12 says xy is equals to e raised to the power x minus y. Now we carefully look at this problem. This is implicit differentiation because y is not the subject of the equation. Y and x are mixed up in the equation. So this is an implicit differentiation. If y is a subject, it's explicit. So now whenever we have to differentiate an implicit differentiation function, when we differentiate the name of the function, like say y is the name of the function, we must attach y prime. So since y is a name, we're going to attach y prime when we differentiate y. So we're going to use the product rule right here because you have x and y being multiplied. We hold x and differentiate y is 1. So we just attach y prime. Plus we hold y and differentiate x, we get 1. Now we differentiate this exponential function. So the derivative of e raised to the power u is just e raised to the power u times the derivative of u. So we rewrite e raised to the power x minus y times the derivative of x minus y. The derivative of x is 1. The derivative of y is y prime. So now we can multiply 1 by e raised to the power x minus y minus y prime times this is y prime e raised to the power x minus y. The aim is to solve for y prime. So on this side we have x y prime. We can send this 1 across, it becomes minus y. So we send this term on this side of the equation, x y prime plus y prime e raised to the power x minus y, or equals e raised to the power x minus y minus y. So we factor out y prime, we're left with x plus e raised to the power x minus y, and then y prime will be outside. E raised to the power x minus y minus y. So we divide this out by this expression and also this out by this expression. We have y prime to be e raised to the power x minus y all over x plus e raised to the power x minus y. So probably your instructor might want you to stop right here, but you can further rewrite this expression. You can further rewrite it. Now we know that e raised to the power x minus y is just equal to xy, at least in a kind of compact form to simplify the problem further. So y prime is just equal to, so this entire thing is just xy minus y all over, also e raised to the power x minus y is xy. So it's x plus xy. So we factor out what is common, y is common in the numerator. So this is x and then minus 1. In the denominator, x is common. We factor out x. So it's 1 plus y. So this is also our final answer. So either this one or this one, whatever the case might be. So we do the last question. And the last question says y equals to e raised to the power x ln of x squared plus 1. So in this case, now we have again two functions, an exponential function and a logarithmic function. We use the product rule. So y prime becomes, we hold one of them, we hold e raised to the power x, and we differentiate the logarithm. So it's 1 over this function, x squared plus 1, times the derivative of this function. So the derivative of x squared is just 2x, the derivative of 1 is 0. Plus, we hold the logarithm now, x squared plus 1, and we differentiate the exponent. So the derivative of e raised to the power x is just e raised to the power x. Then we can simplify it. So y prime becomes, so in this numerator, you have 2x e raised to the power x over x squared plus 1 plus e raised to the power x ln of x squared plus 1. So e raised to the power x is common to the both of them. We can just have it to be outside, and then we can have, but again, e raised to the power x ln of x squared plus 1 is just equal to y. We could decide to rewrite it. So, but let's leave that. So we have e raised to the power x coming outside, and then what we'll be left with? We'll be left with x, 2x right there over s squared plus 1 plus, this is already out, the ln of s squared plus 1. So if we want to find LCD, we can do that as well. We'll just have x squared plus 1, and then this goes into this one is just 1 times 2x is 2x, so it's e to the power x times 2x plus 1 goes into x squared plus 1 is x squared plus 1 times this numerator, so it's s squared plus 1 times ln of x squared plus 1. So this could be our final answer for question number 13. Or if you like I said, you can be able to bring in the value of e raised to the power x ln of x squared plus 1, like we could do it right here. So this whole thing is just y. So we have y prime to be equal to 2x e raised to the power x plus y all over s squared plus 1. So this is exactly what we have, right? And then you can also okay, so that's just it. So you will simplify it like this, depending on what answer you are giving. For instance, if you are giving some practice problems and the answers are available, then you know what to do at the end of the problem. So thanks so much for watching. See you in our next lecture. Thank you.